Okay, great. I think I'm going to go ahead and get started now. So thanks everyone for joining us. This is the online meetup for June, and we're going to review Docker CE latest features. So we have a great speaker for you today. We have Sophia Parafina. She's a developer relations engineer here at Docker. She's been a Code for America Fellow, Director of Operations at OpenGeo, and also an adjunct professor at Hunter. She was also a founder and CTO of Ionic Enterprise, which was required, and a senior program manager for InQCell, the CIA's venture capital fund. So with that really brief intro, I'm going to pass it along to Sophia. Okay, Sophia, I think you should be all set.
Okay. Am I on?
Yeah. Yeah, I think
okay.
You're okay. You're fine to share your screen when you can.
Okay. Hi, y'all. So today they asked me to talk about some of the new features that are coming out in Docker 1706, which should be out shortly, and how it relates. We started using these features a while back before DockerCon Austin, and we built a demo around it to show off some of these features, and I'll go over some of these things. So go and okay. Can you see my presentation here?
Yes, I can see your screen.
Okay. The one with the PowerPoint. Okay.
Well, it's just I don't see a PowerPoint slide, but I see it's like a dark gray.
Oh, it's on the flips. Okay. I don't know what's going on here. I'm sharing. Hold on. Apologize.
All right. So just as Sophia's getting set up, just a reminder that if you have any questions or comments, please drop those in the Q&A section. We have some time at the end, so Sophia will be able to answer questions. And then also, if you have to jump out early, we're recording this meetup, and we'll share the slides and the recording shortly after in a few days.
Okay, so can you see this right here, the Etsy demo shop demo?
Just looks like the event center is showing up right now. Okay, there. Yeah, no, it's strange. Yeah, cool.
Weird. Okay. So this is the Etsy shop demo. It is basically, I think if you were at DockerCon, we showed this briefly in some of the demos. It's Etsy type shop where the images from all the cartoons that we do and use at Docker are available for sale. So the idea behind it was to build out a very typical web application. Some of the elements that we wanted when we started speccing this out as a demonstration project is that we wanted something pretty straightforward, a relational database as a back end, a relational database for holding your data, a REST back end. We wanted to use a Node.js client application. We wanted to be secure and scalable. Basically use the sort of same technology as you would find in most any online store, online shop kind of thing. So a little bit about the architecture. So for this, we chose using Java SE as the application architecture. We used a model. I mean, it's pretty straightforward. Use a model viewer MVC controller type of architecture. What we picked to use was Spring Boot because it was actually very easy to use for rapid application development. It had a lot of the REST components that are there. And one of the nice things about Spring Boot is that you don't have to spend a lot of time configuring XML files. It also includes a Tomcat runtime. So basically, you can produce a jar file and just tell it to run directly. Also, the nice thing about using Spring, we had Spring Data, which creates data repositories in the database, which was PostgreSQL, and it handles a lot of the SQL queries automatically in code, so you don't have to code SQL to begin with. So we use PostgreSQL because it's just available, it's easy to use as well. It's probably the most used database that's been Dockerized. But there are examples in the thing for using in the project for using anything from SQL Server to MySQL or even Oracle as well. Just the catch is that we had to code specifically to make sure that the specific data types for each one of those was applicable across all the different types of databases. And for the front end part of it, I didn't write this part. We had another person at Docker Developer write the React front end, which was the web storefront. It was based on React, it runs in Node. I mean, obviously, we could have used a more traditional JSP client, but we wanted to look at a much more modern architecture than using that. So the other part is we have a payment gateway, which is basically just a shell script that we use it to check secrets and use secrets to check authentication of payments. Basically, it's just a demo kind of demo, and it's a demo thing to just show how secrets are used. So what's not shown in the diagram is we've used Nginx as a reverse proxy and provide HTTPS, and of course the Docker is providing the deployment environment, whether you're deploying it as a swarm or as a stack or a cluster. So go over and set up the project really quickly and show and just building it with Maven, setting the project to Eclipse. Change what I'm sharing here. So if you clone the repository, it's very straightforward. We have a couple of compose files in here. We have a typical Docker compose.yaml file, which is actually runs the entire script and builds all the containers and runs everything. We have a more limited set, which only if you want to just play around with the development aspect of it, Docker Compose Dev just puts up the database and the back end and the front end client together. And also we also have a Docker Stack YAML file for deploying it is a stack. So go ahead and just
Hey, Sophia, sorry to interrupt you. Do you mind making the text a little larger?
Oh, yeah. Sure.
Thanks.
Sure.
Perfect. Yeah, great.
So basically, we'll run through and it'll build up. Oops. Okay. Looks like I have a port open. Okay. Okay. So all these have already been built, but basically just Doc Compose will start up if the containers aren't built yet or you haven't pulled them containers down. It'll run through the process and build the container. It'll start up the app server and set up the payment gateway and just keep on messaging you. So starting it up and building a project is really straightforward, just using the Compose file. So one of the nice things about it is that it is a Maven project, so we can go ahead and just pull it straight into Eclipse.
Hey, Sophie, I think you muted yourself. Okay, I think we'll be back.
Okay, there we go. Hold on, I'm trying to find you. Okay, so one of the first things we'll talk about is the multi-stage builds, which is part of 1706. You can currently find it on Edge right now, but it should be released. I'm hoping you're all familiar with the builder pattern, where you are using different Docker images to build, one, basically build and compile your code and using the results from that build to push it into a second container. So basically, you're leaving your build and tool chain on the first container, and just have your compiled application that you can deploy in the second container. So before, we used to have to write Docker files for the build container, and then use some shell scripts to manipulate it to move that information over. So one of the nice things about multi-stage builds is that we can go ahead and basically orchestrate all of that inside a single Docker file. So, if we take a quick look at it. Okay. So if we look at it, what we do first is we're going to build the storefront part, which is written in React. It's a JavaScript application. So one of the things you can do is, again, typical Docker file, you specify which image you're going to use. And here we're using Node, and right now, what we can tell it that this particular build or image will give it a name. So the label I've given this is storefront. So you have the as statement as storefront. The preferred way, or the best practice way, is actually use names. You can use offsets as well. That's also allowed, but probably the best way right now is to go ahead and use a label or a name on that. So again, specify the work directory, copy all that stuff over, use npm install to build and copy all the modules that you will need, and then run the build. Okay, so same thing we're doing very similar for the app server, where you again use a Maven image. Then we copy everything over, copy the pom.xml, and then we run Maven and copy all the dependencies over, and use Maven to compile it and package it all together. On the third part of this, which is going to be the server part, or the actual where the application is going to be served. So we're just going to straight up use a Java JDK. We're going to add a user. That's so we'll go ahead and add a user. So we're not using a root as a default user. We'll create a work directory, and then this is the best part about it is taking from the different containers we've built here. We just copy from there the application into the directory, into your working directory. Then again, we change it into the application directory, and again do the copy over there. Since we're using Spring Boot, it's using a jar file to do this. So there's no app server. The app server, it's sort of a Tomcat app server already built into Spring Boot. But if you're doing this on a standard, sort of Tomcat deployment or WebLogic or whatever app server you have, you can do the same thing where it produces a WAR file and copy the WAR file over into the web apps directory. And again, here we set the entry point to start up the application, and then we actually have a specific profile within Spring that tells it to use a Postgres database. So that's one of the really nice things about the about having multi-stage builds. Okay. So, so what we've done here essentially, as we went over, we built all the application in Spring, and we packaged everything into containers as well. And you can look at all that stuff there. And let's see. So previously I showed you how to deploy that. You can use the compose file to do that. As when you deploy that application, again, standard compose, you have to init it as a single node swarm to run the application, since we're using a couple of things such as secrets that require it to be run as a swarm, in swarm mode. We also provide a stacked deploy file. So basically the stacks define all these services that Docker orchestrates it. With it, we can define all the environmental variables as well. So let's take a quick look at that. And so one of the things you've noticed is that Stack Deploy, the version's 3.2 on this, and we're using specific Docker, using specific images there. There's a hash that's provided, especially for the first proxy. This was for the demo stuff that we were building. Again, we can also define all the one of the nice things, we define all the secrets that are in there, the sources and targets, and keys as well. We'll talk a little bit about secrets there. And same thing with databases. We're pulling down the images from Docker samples. Again, environment, all this other stuff that's in there. We add in the database as a worker, and then we're also the service itself. Typical stuff when you're deploying a cluster. We only have 2 replicas there for this, and again, restart policy, all the same stuff that you typically find if you're setting it up. In this instance, we also throw in a visualizer so you can actually see the visual representation of where all the containers are running and there's different status. Payment gateway, again, is to verify tokens that's used in the application. Again, networks and secrets are all part of the Stack Deploy. So we run this. So let me answer some of your questions here. Okay, so one, yes, the repo is publicly available under GitHub Docker samples. So does this have an application in minimizing Docker file size and build speed? Yes, it does actually minimize the Docker file size because you're not carrying over your tool chain or build stuff into your final application. So in this case, we're using Maven to build the application, and you can just bring in only the things that you need or the finished application, which is a jar file or a war file. Okay, so what happens with the containers at the beginning of the build? Are they discarded? I mean, if it's not an open source project, we don't want the source code within the image. With the multi-build, yes, the intermediary containers that are built where you're building your application are discarded eventually. You do notice that there is a tendency sometimes to have some orphan containers there, but then you can clean out. They're not left, they are typically discarded when you're building that. What about piece? Okay. So the question is, what about Postgres storage type in Swarm? For this application, we don't have an external storage volume where we're holding the pSQL data files. However, we have written into the project the configuration so that if you wanted to run multiple instances or multiple instances of PostgreSQL, there is a failover mechanism that's been written into the configuration of that particular image that we've put together there. The thing about PostgreSQL is there is not a way that we could see to actually automatically trigger to fail over and switch to another instance. It actually has to be done manually. So if it goes down, the switch would have to go manually. Kind of post the repo and the objectives by the end of this talk. Okay, yes, definitely. So the repo is okay. Yeah, definitely, I can do that. Okay. So one of the nice features is being able to use a multi-stage build. So one of the other parts, it's been around for a little, using secrets. Um, we usually, obviously, secrets and part of the 12-factor model or 12-factor model, so using setting the type, setting passwords and things as basically environmental variables to draw from. It's not necessarily secret things, so we've implemented secrets for a while. One of the things that for secrets to work is that Docker has to be in swarm mode, so you have to initialize the swarm. If you're running as a Docker Compose, it will be running as a single node swarm. So what's a basic secret is that it's any blob of data or password, private SSH key, a TLS certificate, or any other piece of data that you think is sensitive in nature. And basically, when you add the secret to a swarm, Docker sends the secret over to the swarm manager, and through TLS connections through there, and it also has a built-in certificate authority that gets created when you start up a new swarm. So basically, the manager allows the different workers, or is very specific on which workers can have a specific secret. So secrets are not available to all the workers in there. They're specified to it. So secrets, the nodes themselves can't request secrets, but they only gain access to them when they're given by the manager. So we did a couple of things here in the application. Is that one, we created secrets. We created secrets at the command line. You can do that basically. We also have, if we look at the compose file, we create secrets by setting them inside. We set them inside a specific file with a Postgres. The label for that particular secret for the password is Postgres password. We also have one for payment token. One of the things that you can do as you get in the Postgres password is for the application to find that. So that since we know where it's going to be in run secrets Postgres password, it's pretty easy programmatically to incorporate that into your application. So you can see an example here of where so it's kind of straightforward where you can read it where you run the secrets here. So for us, we just actually just do a file reader from the Postgres password and retrieve that password, and we put it back into the configuration as part of the data source properties, and that's how the application actually gets the secret from there. So it's very simple and easy and straightforward to use from a programmatic viewpoint. Okay, so actually, there are different ways of setting up secrets. So again, create in command line. We can specify them from a file and compose. I showed you where you can pick it up in code. And actually, I have a blog post about creating secrets inside Docker Data Center. If you're using that, that should be out shortly next week as well. But basically, it's just going through the menus and adding secrets and adding it to the services themselves. Okay, so that's pretty much what I have for today. Are there any further questions?
Okay, looks like there isn't any more questions.
Okay.
Great. Well, thanks, Sophia. I really appreciate